Okay, hello everybody. Today we'll be making a runtime painting system. As you can see here, every time a Niagara particle collides with any static mesh, this rock, for example, it will spawn a blueprint, and that blueprint will allow us to modify the material of this rock. For example, here you can see whenever a particle collides, I'm leaving behind this white dot. So this could be used to represent snow. While I will be recreating this effect in this tutorial, you can use the exact same technique to do a bunch of other interesting stuff like whenever this particle collides, you can spawn another Niagara system for like secondary debris or bullet impacts or whatever. You can also make this material system much more interesting by changing the roughness values or adding emission. You can really do anything you want here. So with that intro out of the way, let's get to recreating this. So I'll start by closing this and file, new level, basic, and create. Let's not save this. So this gives me a clean working plate. I'll also save this, save, and I will create a new folder. I'll call it painting system. I'll go inside here and I'll create another folder and I'll call it levels. Okay. And here I will name this level L-tute. Okay, we are now painting system levels here. Let's save. Okay, we are now here. The first thing we want to make is the Niagara system, which are the particles that are actually falling down and they collide. So to do that, let's just right click, create a new folder, call it Niagara. Here, right click and Niagara system, and we'll create an empty Niagara system. You could start from a template, but I'll show you how to create this Niagara system from scratch. So create empty Niagara system and I will call it NS particles. Okay, you could have also noticed the keyboard down below. So if you ever get stuck on what shortcut I pressed, you could always look below. Okay, I will dock this here. And by the way, when you're starting, you would probably not see this black window here. To get that, go to Window, Preview Scene Settings. Yep, there you go. And uncheck Show Environment and turn the environment color all the way to black. I like to do this because by default, it's something like that and the particles are not really easily visible. So just do that. And right click here, add a minimal emitter. This sets up with a few nodes which we'll need. Now I want particles. So to get particles at the emitter update, right click plus this add button and search for spawn. And we'll take spawn rate. What spawn rate does is, if you go back to the details panel, it will spawn the specified number of particles per second. So let's just spawn say 5 particles. And right now nothing's changing because they're all spawning at the exact same location. I want to change their initial location. So whenever I want to change something initially, I use the particle spawn. So I just search for the shape location module. This randomizes the particle's position, which is specified by the shape we define here. I want them to be on a plane. So I'll set the shape primitive to plane, a box plane, and set plane. And right now the particles are way too big. We can actually reduce them by going to initialize particle, the one that was already given to us, and scale sprite size to uniform. We could reduce this even further if you like. And now you can see they are on a plane. Now we want them to fall. We want them to fall by giving them gravity. And since gravity is continuous, it needs to go into particle update. So particle update is something that is called every frame per particle. What particle spawn is called once every particle is born. So let's just go to particle update and I'll give it gravity and enter. Now we get this module unmet dependency error. We can just press fix issue and it will add this new solve forces and velocity module. And now you can see the particles are falling, but I don't want them to fall so fast. So I'll just reduce the gravity to something like -200. And yeah, that's fine. Now I want them to collide. it can happen anytime in its lifetime. So we'll just search for it in the particle update and get collision. Okay. Yeah. Now they're colliding and I want them to die when they collide. So if I just press on collision, if I just select kill on collision, and they are dying when they're spawning, and ignore this flickering, it's just colliding with something that doesn't really exist. Okay. Now I want to send the particle data to a blueprint, and of course that's again, I want to do that continuously. So once again, particle update, and I will search blueprint. And the module we want is export particle data to blueprint. I just select that, and you get this module usage note that says there is an example on content examples, which showcases the use of export particle data to blueprint. I recommend you go through it. It's quite interesting. So the condition to export data, when this is true, it will send the data. When it's false, it will not send the data. So I wanted to send the data only when a collision has happened. So to do that, I can tell this chevron, and if I just search for collision, there is this collision valid property. If I just select this, it will be true when a collision has occurred, and it will be false otherwise, which is exactly what we want. And the next step we need to do is set this callback handler parameter. So the way we do this is go to the user parameters. If you do not find this window, just window and user parameter, you'll get here, and click this plus button here and search for object. And it's this one, and I'll rename this to particle carrier because this will be carrying our data. Yes. Capital P. Okay. Perfect. Now I want to set this callback handler parameter to our particle carrier. And that is pretty much it. I'll compile and save this. Perfect. Now I'll create a blueprint which can actually read this particle data. So I'll first create a new folder, blueprint, and right click, blueprint class of type actor. We do not want anything, we want the simplest actor, and we just do BP paint system because we will be painting. Okay, you get greeted with this window here. I'll add a Niagara particle system component. So now we can, in the Niagara system asset, add our NS particles that we just made, and you can see the particles are falling. Now I also want to add the rock. To add the rock, I can do a static mesh and get the static mesh, and this is the rock. Okay, I'll move the Niagara system up. Okay, right now you can see the static mesh is the child of Niagara. We do not want that. So I'll just take the static mesh and drag it and attach. Okay, this removes the parent-child constraint that we just made accidentally. You just select Niagara once again and move it up. And now you can see the particles are not going down. That means they are dying, and they are dying because they are colliding with this rock, which is exactly what we want. Now what we want is go to class settings. In the implemented interface section, search for Niagara, and the first one, Niagara particle callback handler. This gives us this node. Let's first set everything up. Go to the event graph of this blueprint. Delete these two nodes, you do not need them. And in the Niagara, just drag and drop here and search for set Niagara object. And we want the set Niagara variable by string object. So what this does is sets a Niagara variable of type object. Remember, this particle carrier is of type object. And we just want to do this on begin play. And the name is, of course, particle carrier. The spelling is everything important. Sorry. And we want this to be cell, which is this blueprint. So we just search for cell, get a reference to cell. And now this particle carrier for this Niagara system will send the data to this blueprint. And to further read this data using the interface, we can just double click here and we get event receive particle data. And this is the actual data. If I do a for each loop here, for each loop, I can iterate through all the elements. And if I search for break here, I can break basic particle data, and I have position, size, velocity. Okay. Now next, what I want to do is spawn something when a collision happens. But first, let's actually visualize this data. So if I just search for, let's just print the data, print string, and I'll print this. If I compile and save, and I drag this BP painting system here, and if I press Alt S to simulate, you can see every time a collision happens, we get another entry here. Okay, so that means everything is working exactly what we want. Now I want to go back to the Niagara system, and in the export particle data to blueprint, there are these three options: vector to send, and float to send. If you hover over them, you will see that you can actually send whatever you want here, but their names are fixed. So what I want is to also get the normal of the collision. So what that will allow me to do is, say a particle collision happens here, I want to spawn a plane that is aligned to the surface normal. So it's fairly easy to do. In the abstract velocity, I can just twirl this down and search. If I search for normal, there is this collision normal. So I'll just select that, save and compile once again. And in the BP paint system, I can actually delete all this. And I want to make a note that the velocity is actually the normal. So I can do this comment, and I'll just write velocity is actually normal. Okay. Now using this position and normal data, I want to spawn a blueprint. Let's actually make that blueprint. If I right click, blueprint, actor, and that will be BP spawn, say for example, because we are spawning this, and I just want to keep it as a plane. Okay, we get this. Just compile and save. And in the BP paint system, search for spawn actor from class. This specific node, get that. And here you want spawn, BP spawn, the one we just made. Okay, let's plug this in. And in the spawn transform, I'll just drag from here and search for make transform from Z axis. So what this will allow me to do is specify a location and a Z axis. The Z axis will be its up vector, and I want this up vector to be, of course, the normal of the surface, so everything is properly aligned. I just search for, drag this here, and another thing I want to do is just add a collision handling override to always spawn, just so it always spawns. Now if I compile and save this, let's try and visualize this. Okay, that seems to be working. I want to reduce the number of particles spawned. So in the spawn rate, let me just actually reduce it to 2. So that's just 2 particles per second. Let's play this once again. Yep. And that's looking pretty good. So now the paint system looks like this, and that is all we need to do. Now let's set up runtime virtual texture. So what I want to do is, when this is spawned, it will write to a runtime virtual texture, and the material of this thing will read from that runtime virtual texture. So we can change that on runtime. So let's just do that. The first thing we need to do is, let's just create a new folder, name it RVT, enter, and I will texture runtime virtual texture. So RVT, I'll name it canvas because we are painting on it. You can actually go inside and change some settings here, but we won't need to do that. Okay, now we need to add a runtime volume. There are multiple ways to add that. You can go here and search for runtime virtual texture volume, or you can even go to the place actors window, which is window, place actors, volume, runtime virtual texture volume. So you can just drag and drop this anywhere. And in the details panel here, specify the RVT canvas that we just made, and scroll down a bit and bounds align actor. In the bounds align actor, you can just use this eyedropper, select the paint system and set bounds. So this will set automatically reposition and rescale the box so that it encompasses our blueprint. Okay, now that this is done, let's create materials. I'll first create the material that will go on this thing. So new folder, material, and right click material, and this will be M brush because we are painting with this thing. Okay, now just for demonstration purposes, I have created a circle material function. This will give me a circle and I can specify its radius and some other properties. So to get started, I'll press 1 on my keyboard and click anywhere on the mouse. This will give me a single parameter node, a single scalar node. To get a parameter, you press S. Actually, let's use parameter. So get rid of this. The first parameter will be F2 to rename. This will be the circle radius. And its default value, let's say, will be 0.2. And we plug this in. And I only want to change this. So I want these two to be constants. So I'll 1. And at the circle boundary, 0. And at the circle center, I want this to be 1. So what this does is at the boundary of the circle, it will have 0. And at the center of the circle, it will have 1. And I need to pass in texture coordinates here. So I'll just search for texture coordinates. There you go. And I want to visualize this on a plane. Right now it's not connected to anything. If I just plug this in here, you can see I get a simple circle. And you can change whatever you want here. The implementation of this circle will be in my notes. I do have a complete document that covers everything in more detail on my GitHub, which will be linked in the description down below, along with some beginner notes for Unreal Engine. But the notes will take you from beginner to an intermediate level. Again, on my GitHub, linked below. Now here, what I want to do a few changes. Because we don't actually want to see what this is spawning. So for example, if I play here, I do not actually want to see this plane. Okay, by the way, something you might have noticed, the collision is not really accurate. Let's fix that. So if I just select this static mesh here, its collision is currently set to simple collision. I want to use complex collision. So what complex collision is, it uses this exact mesh for collision, whereas it is currently using a simplified mesh, which is often called the convex hull for the collision. So that's simple enough to do. Just scroll down here and in the collision presets and collision complexity, just use complex collision as simple, and that should fix the issue. If I do here and all test now. Yeah, okay. Now that looks much more detailed. Now, yeah, as I was mentioning, I do not really want to see the plane that is spawning. I just want to write that to RVTs. So to do that, I will alt click here to disconnect the connection, and I'll change the blend mode to translucent gray. This will allow me to have a small simple fall off. Yep. And the shading mode to unlit, because we really do not want any interaction. The main node that we need is runtime virtual texture output. This will output everything to a runtime virtual texture. So for now, I'll just put everything here. The important ones are base color, opacity and mask. Roughness, I'm just putting it as is for now. And in the opacity here, I'll put this. Now compile. Okay, and now if I go to BP spawn and I want to select this, so just search for brush here, M brush, and you can see something happening here. It's black here and it's completely transparent on the borders, which is exactly what we want. Okay. Okay, now let's modify the material of this thing, the rock. So to do that, let's go to yep, and create another material that is the M canvas, for example. Now the way I want to set this up is use the original textures found for this rock and just modify that. So the textures for this rock are on in content, fab, megascans, 3D, granite rock, medium, distress. Now, of course, this would vary for your specific asset, but I'll just add these in. This is the base color, so this will go in the base color. This is the normal, this will go in the normal. I could not figure out where this thing goes, so just ignore this. This is the ORM map. ORM stands for opacity, roughness, metallic. So opacity, roughness, metallic. I'll put the roughness here and I'll put the metallic. Where is metallic? Metallic is here. I do not see a slot to plug in opacity, but we don't really need to plug in opacity, so that's fine. The main node we actually need is runtime virtual texture sample. And here we need to specify which virtual texture to sample from, and we'll just select RVT canvas. And for the purposes of this video, I'll just modify the base color. I'll drag and press A on my keyboard. This will add an add node, and I'll add the base color and put this here. Now if I just apply and save, in the BP paint system, I'll change this to canvas. Okay, no visible change, that's good. Now, the last thing we really need to set up is to correctly write to the runtime virtual texture. So in the BP spawn, select plane, and you need to scroll down a bit, and we'll turn off some buttons. First of all, let's actually disable as many as we can. We don't really care about them. The main one is render in main pass. When I check that off, you can see it's not rendering in the main pass, but it will still render to the virtual texture. So let's just uncheck everything. Okay, and the next very important button is draw in virtual texture. We need to add which virtual texture we need to write to. We just do that and RVT canvas. Okay, some more settings I want to turn off from collision. I do not want to generate overlap events, and the collision preset, no collision. So we do not want them to collide at all. So if there are some more settings, yeah, we do not want it to cast shadow either. We do not want it to affect any lighting. We do not want it to do anything. Okay, I think that is pretty much it. If I just compile and save this now, let's Alt S and simulate. Okay, you can see that it is working now. We are not seeing the plane, but the material on the plane is being rendered onto the runtime virtual texture, which is then being sampled by the rock material, and which is then being added to the base color, and we get an effect like this. So this could very easily be snow or whatever else you like, really. So this was extremely easy to set up. Now one last thing I want to do is add fade. So right now these are consistently, they just, when they spawn, they stay there. But what if you want a fade? So to set up fade, it's fairly simple. I'll go to the BP spawn. It's an entirely blueprint driven thing. So on event graph, just delete this. I'll get the plane and I'll search for create dynamic material instance. And here I'll just search for get material. This goes here. This goes here. Okay. And I'll just promote this to a variable that will be dynamic material. Now what I want to do is, once the plane is spawned, I'll just add a timeline node which will gradually go from 1 to 0. Okay, but to actually set that up, you need to go into the brush and we need to add something here, or rather multiply. So what I want to do is, let's get a scalar parameter node and I'll make this fade out, default value 1. And what I'll do is drag from here, press M. So this will get a multiply node, get this, and put everything here. Note that I did not use the roughness channel anywhere, but okay. Now apply and save. Yeah. So it would be better now if you just right click and create material instance, mi canvas. So what a material instance allows us to do is change the parameters that we made. Okay, did not need to make it of a canvas, of the brush we need. So right click, create material instance, mi brush, perfect. So now these are these two parameters that we made. And of course we cannot see anything here, but they are being, they do influence. Okay, so I will go to BP spawn and I will change the M brush to MI brush, which is the material instance. And in that material instance, I want to change a material parameter value. So if I just search for set material parameter, I want to set a scalar parameter value, set scalar parameter value, because the fade out parameter was indeed a scalar. So I do this and it asked me for a parameter name. That was of course fade out. And now this we want to change dynamically. To do that, after begin play, I'll search for a timeline node and just press add timeline. I'll rename this to fade out. Okay, and on update we want this. Okay, now if I just double click to open this, I add a new track, add a float track, and this will be the fade out track. And we want the length to be, yeah, okay, I guess 5 seconds is enough. So at 0, at the moment it is spawned, it will have full influence, but after 5 seconds it will have no influence. So I just right click, add key, and at time 0 I want its value to be 1, and right click, add another key, and at time 5, which is the end, I want its value to be 0. Now if I press these two buttons to make the graph in focus, okay, I'll just scroll down here, select all of them, and right click on this keyframe. I can change their key interpolation, but right now linear is perfectly fine. I'll go back to the event graph and you can see this fade out parameter. I'll just plug this in here. And now our material fades out from 1 to 0. And when it's finished, I want to destroy my actor because we do not need it anymore. So what happens here is on begin play, I create the dynamic material instance for this plane and I change this fade out parameter to go from 1 to 0 so that effectively nullifies its influence. And after that's done, after that is finished, we just destroy ourselves. So if I compile and save now, Alt S to simulate. Okay, so it was indeed working, but the effect was extremely subtle. So I just added this multiply node here, which bumps up the values to 10. And now if I actually just see that, just compile that and Alt S, you can see we spawn and we are gradually fading out over the course of 5 seconds. And that is pretty much it. A few more things I can show you is in the BP paint system. Instead of the spawn actor, you can actually search for like spawn Niagara. So that is spawn system. And here you plug in a Niagara system and you can even spawn decals. You can do a lot of interesting stuff here. One of the main reasons I used RBTs instead of decals is because here I can do much more interesting stuff. Like I can lerp this, which is just pressing L, lerp this, something like this. So what this will do is whenever the roughness is close to 1, I'll get a roughness of 0. Otherwise, I'll just get the original. And so this gives me a lot more control to how I want the texture to be used. Now you can see the object is a bit shinier, which may be what you want. So that concludes the tutorial. I hope you found it helpful. I do have, as I mentioned in the middle of the video, I do have notes for the exact thing. They are found on my GitHub and they will be linked below. Okay, if you do use this effect somewhere, please let me know. I'd love to see it, and see you later. Thank you. Bye-bye.